Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmed Shamshiri. In this video, we are going to learn how to use this VL6180X proximity time of flight range sensor. This has a lot of application in robotics to detect objects surrounding up to 20 centimeters. I'm going to explain the module, then I'm going to show you how to download and install the library. After that, I'm going to show you how to do the wiring. Code will be explained after that with one sensor, and also code will be explained with two sensors. To test it with single sensor, I'm going to show you also how to use two of this. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. VL6180X from ST Semiconductor. This is actual sensor, that tiny. This is used for proximity sensor in mobile phones and tablets and many other devices. So this is just for 20 centimeter with very accurate reading. It can be used for 62 centimeter. Resolution will be reduced. We have VL6380X for 2000 millimeter or 2 meter, and then VL6380X. So it's not useful to change this and try to get further distance, because this will be just for 20 centimeter, and 20 centimeter is enough for many applications. I'm going to show you how to use two or more. The code that was there was not easy to use and ready, so I'm making it very easy for you to grab the range and use it for your application. This is the VL6180X module. They are shipping it like this with this pin headers. You can see we have all these pins here, 7. This can work from 2.8 up to 5 volts, 5.5 volts, and this is a ground. This is 2.8 volts output, and also it has been connected to the regulator. This regulator, in case for some reason if you have 2.8 volts, you can connect it here, so you can power the sensor directly. And the pins are labeled as VN. The second pin is here 2.8 volts. That is output 2.8 volts you can take, because that's connected directly to the regulator. That's the regulator. And you can also input 2.8 volts in case if you want to power it with 2.8, which I will advise against it. And this is a ground. This is the GPIO1 pin, which can be used for interrupt and other purposes. We're not going to use that pin, and we are not going to use the 2.8 pin. This is shutdown pin. This is used when you want to use two or more of these together in order to turn this on and off with software. And also, if you want to control it or turn it on and off with software, you can use that pin. Then the next pin is SCL. That is the clock pin for I2C. And then SDA, that's the data pin for I2C. We have two MOSFETs here. These are the logic level converter that make it possible to be used with 3.3 volts or 5 volts. So when you connect 5 volts here, the module receives 2.8 volts, and these two MOSFETs here adjust the level for I2C, so it can work with 3.3 volts and 5 volts. There is a backside. You might find that somebody else will sell it without this, because the module is not important. The important part is this. This is the sensor. When we use two or more of these sensors, then we need multiple I2C pin and multiple 5 volts, so we need to use a breadboard. Now let's solder it. I'm going to insert the header pins from the bottom. And my finger. And here is a data sheet for VL618. As you can see, this is a proximity sensor, laser assisted autofocus, smartphone or tablet. When you bring it to your ear, it detects it. The maximum range is 62 centimeter, uses I2C. And here the size is 4.8 by 2.8 by 1 millimeter. And the ranging, you can see it says maximum 62 centimeter, and the operating voltage is 2.6 to 3 volts, but we have a voltage regulator, we are not worried. And ranging power consumption is 1.7 milliampere. When it is in standby mode, where you can set GPIO 0 to 0, then it will go to standby mode and it consumes less than 1 microampere. If you use software, it will be still less than 1 microampere, not to read anything. Operating temperature is minus 20 to 70 degrees Celsius, and the infrared emitter wavelength is 850 nanometer. The I2C frequency of the bus is 400 kilohertz. The address by default is 0x29. The actual pins, like this, we have GPIO 1 and GPIO 0. And GPIO 1 can be used as an interrupt. GPIO 0, it sets to sleep mode to default enable chip. This enables it. And then we have the other pins, which we are not worried because we are using the module directly. As you can see, it has two operating range. One is single shot measurement, the other one is continuous. And we will see if it is accommodated in the code. We can continuously use it, and using an interrupt, we can send it to sleep or enable it to activate, and this way save the power. And in continuous mode, which is 10 hertz, that's important. It measures 10 times a second, and total range execution time is 35 milliseconds. Here are the errors. These have been accommodated in the code. No error, system error, early convergence, estimate time, maximum convergence, ranging error. I will provide you the datasheet if you want to have a look at it for further information. Now let me explain the wiring. The last pin is 5 volts. It has been connected to the 5 volts of Arduino. The second pin is 2.8 volts. It's not used. The third one is ground. It has been connected using this gray wire to ground of Arduino. And from the last second white is SCL. It has been connected to the last one. And the last pin is SDA. It has been connected to the second pin. Pay attention. Now let me explain the wiring. From the left, 5 volts, and then in order, ground, and then the middle pin, this has not been used. Later on you will see why. And then the white pin, A5, A4 is connected here, and A5. So this has been connected in the same order. And these lines are now available up to here for our application. You're using this type of breadboard, so you can do the same thing in here. So this area is exactly the same as this. And then for the sensor, I've connected the one wire, the blue, and then empty, and then the second wire, and then empty here. And then gray is connected to this shutdown pin. And then these two have been swapped, meaning this wire, this from the last second one, is connected to the first, and the first wire is connected to the second one. And you will see it why, okay? So here. Then we have connected two of these. And now here for the sensor, I've connected. Here for the sensor, I've connected the sensor to the breadboard like this, empty. I've left one wire empty, and that is the wire here. And also I've connected now the second sensor and the middle wire. So one wire will go to 7 and the other will go to 6 from these two sensors. Now the middle wire from the breadboard, this is not being connected because we are using these two wires. This cannot be shared. Now let me show you first to install the library. Go to Tools and Manage Libraries. Wait for this to complete. Type here VL6180X. Once you typed it, you will see here Adafruit VL6180X. Mine shows installed. In your case, you will see this install button here. Click and install it. The library will be installed. After that, if we go and click on File, Examples, scroll down, and you will see here Adafruit VL6180X. And here we have 3 examples. One is for OLED, the other one is just for simple one, and then the triple one. Now let me explain the code for a single sensor. Go to File, Example, scroll down, Adafruit VL6180X, and then open the first one, which doesn't have any other extension, just the name. And here is the code. We initialize the I2C communication by wire.h. That's part of Arduino. This is the library that we have just downloaded, and we are creating V1, an object from this class. We initialize the serial monitor with 1200, which must match. If I open the serial monitor, the number at the bottom must match. And this is just printing the text. This line is initializing the sensor, and if it is not true, then it will print this text for us that there is an issue. This while one mean stay here forever, and then it will print this text if it passes through this line, so we know the sensor is found. And inside the loop, we are just reading the lux. Here this says lux, the intensity of light, and this is just printing it as a text, which we do need for our application, I believe. And then this is reading the range, storing it in this variable, and this is also checking the status and putting it in this variable. And this status has some reference that have been defined inside the library, and if there is error none, it will print the range for us, this range, that variable. Otherwise we will get all these errors, which we don't have to worry about it, and we have 50 millisecond delay. So to use it for any purpose for one sensor, here is what we do. If range, for example, is greater than 76, that 76 is millimeter. If the range is greater than 76, then do something here, or less than, or whatever you want. You can do that by less than or equal with it. So you can do some action in here. And here is the code for the 2 sensors. You will click on File, Example, and Adafruit VL6180 and select triple. I have taken that code and modified it so it can work with 2 sensors. The explanation: this is the library, we are including it, and here we are defining the I2C address for the sensor 0x30. So that's our first sensor, LOX1, and then 31. Now this LOX with lowercase and uppercase will be used throughout the code. Will be used. If you want to use the third one, just enter and put like this, make 3, and then make this another number, just increment it 32 and continue. This was already 3, I removed it. And these 2 are defining for shutdown pins, 7 and 6. We need to shut it down in order to assign the address to different sensor. And these are the GPIO pin, which are not using it. You can do interrupt and other calculation, and this is for timing. Do not worry about them. And here from the class, we create an object called LOX1 and LOX2. That's a sensor 1, sensor 2 from this instance of the class. If you want the third one, just put this below it, and forth and so forth. Then this is the most important one. We are passing this object as a reference, creating an array here. So this is LOX1, LOX2, and if you want, just copy this and make 3 and 4. Make sure to put this comma in between. And here GPIO LOX1, LOX2 is also, I have not used them, but I've left them there. And inside the setup ID, we are turning all sensors off and then giving it 10 seconds to go off and then turning them on. This is and resetting, giving it 10 seconds. And then we are turning off the number 2 and just keeping the number 1 on. And this is activating LOX1. After that, we are initializing the LOX1 by using LOX1.begin. And if we get any error, and if it's not true, we are printing this text, and also while 1 mean wait forever. And after that, we are assigning the address that we wrote at the top of the code to LOX1. So this is assigning the address and give it 10 seconds to execute. We are turning the second sensor, the pin, high. Remember, this was the first sensor, high. The second was low. Now this is high. And then initialize by using the LOX2.begin. Exactly the same thing. If it doesn't work, we keep it waiting forever. Otherwise, we assign the address to LOX2. So you do the same thing, and read sensor is reading. This function is not being touched. Even if you have 1 or 10, it will just work continuously. Do not worry about this. And this line, I've modified it, and if the status is equal true and there is no issue, I'm passing this range to this temporary range for variable that I've defined at the top of the code. And in here, this function will read sensor 1, it goes and reset, and after that we are getting the range, the temporary that we have just stored, because this function is reading it, storing it in this variable, and now in this line we are getting it and storing it in this array for sensor 1. So sensor 1 starts with 0, and then we are reading sensor 2, and the value will be in this variable, and then we are storing it back in this array as number 1. So 1 is for sensor 2, and the same way you can copy and paste it. Make sure that for sensor 3 make this 3, and here make this 2 in the next line. Inside the setup, we are initializing the serial monitor with 15,200, and that is a value, and we are defining these 2 pins as output. If you have the third one, put it here. This is for the timing, which I have not used. Again, these 2 GPIOs, I have not used them. The shutdown pins, initially we are setting them low. Timing also setting it low. And this is just a text. And this line is setting the ID, which I've explained it at the top of the code, where it turns on and off pins to assign this address. This line is reading the sensors, and here I'm printing the all sensors using this sensor count variable, which is at the top of the code. It holds number of sensors. For example, in this case, if it is 2, then I starts with 0 and then 1 and exits. If there is more, it will continue, and then it will print this I for us, and then this is the line where it gets the sensor with I equals 0. That's getting the range for us, and printing millimeter at the end. And that function, this is done using this text. This for loop is printing this line for us. If you want to use this sensor range for some purpose, here is how you use it. For example, if you want to check sensor 1, F, type here 0, F sensor 1. The distance of sensor 1 is greater than 76, for example. You can do something here. Turn on the motor or turn it off if it's a robot and you're avoiding obstacle. So whatever you want, do something here. You can do equal, smaller or greater, whatever number you want to put. And if you want sensor number 2, just put this 1 and so forth. 100 millisecond delay, and that's the time needed for the reading, the slowest speed of reading. Now let me demonstrate it with a single sensor. I've put this cardboard here in front of me, and the ruler is here. Let's put it at 70 millimeter at this point, and we are reading 70 millimeter, very accurate. Let's go to 100 millimeter, and this is very exact. 150 millimeter. As you can see, this is very accurate. 190 millimeter, and this is just at the edge where it rejects the rest. By the code we can increase the distance, but not worth increasing the distance because there are a lot of other modules VL. So as you can see, when you go 20 centimeter and beyond, it will reject it. But the rest, let's go very close, 10 millimeter, and as you can see, it shows it fluctuates between 10 and 11. Some also I have that the distance also is not proper. 10 millimeters, 20, and I'm moving it slowly. 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 30, and as you can see, it responds very fast, and the speed of this is now being slowed by the serial monitor. If you remove the serial monitor, it can react even faster, but between 30 millisecond is needed for single measurement. And here is a demonstration for two sensors. I've connected two of these, and you will read with sensor 0 and sensor 1, and here, and that's the distance. These two are currently reading, and let me put them on top of each other at 100 millimeter. There is some, let's put it, make sure that's very exact. So now it's exactly 100 millimeter, and that's our reading on the screen. Now I'm holding one. Now I'm holding one at 100 millimeter. Now I'm holding one at 100 millimeter and then moving the other one. As you can see, it shows 68. And if I point it away, so we are reading separately two sensors with different reading. Thank you for watching. This was how to use this VL6180X proximity time of flight sensor. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. I'm going to measure the temperature using this MAX 6675 with K-type thermocoupler sensor and ESP32 with Bluetooth touch, and read the temperature in Celsius, in Fahrenheit, or in Kelvin using your mobile device.